And here we go, lesson 5.2.1. What is a limit? So that's what the chapter is, calculus concept of a limit. Today we're just going to scratch the surface on that, learn a little bit about what a limit is. And where our adventure begins there is with 5-41. So if you want to turn to 5-41 in your book, and if you need to take time to go ahead and set up yourself a coordinate plane, push pause and do so. Otherwise, we're going to sketch the graph f of x equals x minus 2 plus 3. So remember back in Algebra 2 we did this. Here we go. We're talking about a right shift of 2 and an up shift of 3. Okay, don't forget that when we're doing this, we're placing our asymptotes first. So right 2 puts us at positive 2, and the reason it's to the right is because inside the function is opposite. Up 3 moves us up 3, and keep in mind that this is sort of resetting our axes. And then we're going to use this as our reference when we sketch our hyperbola. There is no stretch, there is no negative signs, so it's just a good old-fashioned hyperbola from way back in Algebra 2. Remember, it's a sketch, especially for limits. Okay, when we're talking about end behavior of a graph, we don't really need to have it down to the detail, because we're not talking about in particular x values. We're talking about what's happening to the graph as we're approaching certain places. 5-41 says place a bold dot on the point of the graph corresponding to x equals 5. There's 5 on the graph at that place would be right about here. Okay, and then they're talking about our new character, our new friend, Benny the Bug. All right, and it says that Benny the Bug starts at that location and crawls along the curve, moving to the right. So here's Benny. You're going to get my best rendition of what Benny the Bug looks like. He's a ladybug. And he's crawling on the curve going to the right. Now the limit here is all about where does Benny think he's going. He can't actually see the end because he's just a little itty-bitty bug on the ground. Sort of like you. If you're walking along the earth, yeah, you might feel like you're walking on a flat surface, but in the grand scheme, everything, it's a spherical shape, so everything's curved, even though you can't really tell it at the particular place that you are walking right now. Okay, just like the Earth's rotating, you can't feel it. All right. So as Benny crawls along this line that we sketched, what y value does he think he's approaching? He thinks he's approaching the y value of 3. Now, will he ever reach the y value of 3? And hopefully you learned this in Algebra 2. Will he ever get there? No. Because at that particular y value of 3, there is a horizontal asymptote. So it will never actually equal 3. It will get so close that you can't tell the difference between where you're at and 3, but you'll never actually reach it. Okay? So remember there, limits, the answer to a limit statement is always going to be what kind of value? A y value. Put a star next to that, or 3 stars, or write that in your toolkit, or write that in your key notes on your purple sheet. Take a look at another example here, 5-42. In 5-42, I already have this sketched. If you need to sketch in your notes, do so. Otherwise, you should be able to follow along in the book. Consider the graph at the right and answer the following questions. Part A, Benny the Bug again. Benny's over here. Okay, he's at the point corresponding to x equals 6. This is where Benny the Bug is. Benny is crawling to the left now. Okay, as he's climbing up the hill, again, he can't, I realize here he looks really enormous, but you gotta be able to see him. But he can't see the end. Okay, so what value does Benny think he's going to? As Benny's crawling along this curve, you little itty-bitty bug crawling along this curve, where does he think he's going? What y value? Again, that y value is 3. Will he ever reach 3? No. Why not? Why will he not reach the y value of 3? Correct. This open circle, okay, means that graph goes all the way to just about 3, but never actually gets to 3. Benny doesn't know that. Okay? Another analogy could be, say, Miguel is at Sheetz in Hanover. Miguel gets in his car. He's going to meet Danny at Cross Keys in New Oxford. Okay, so Miguel's coming from Sheetz. Danny's coming from 7-Eleven in New Oxford, and they're planning to meet at Cross Keys in New Oxford at the Turkey Hill. However, unbeknownst to them, there's an explosion, and basically one of the gas tanks blows up, and there's nothing but a hole in the ground. Okay, from Sheetz in Hanover, does Miguel know that? No, he doesn't. From the 7-Eleven in New Oxford, does Danny know that? No, he probably doesn't. Maybe they see smoke. Okay, depending on how big the explosion, they can feel the earth shake. Okay, but they don't actually know that Turkey Hill doesn't exist anymore. So while they're driving in their cars planning to meet there, where do they think they're going? They think they're going to Turkey Hill. Is Turkey Hill still there? No. But that doesn't matter. In a limit, that doesn't matter. The limit is what is the end behavior? Where do we think we're going? Okay? Part B is Bertha, Benny's sister. Okay? Also David's girlfriend. All right, and Bertha's climbing along this curve, also approaching this x value of 3. Okay? As Bertha climbs along the curve, approaching the x value of 3, what is the limit? What y value does she think she's approaching? Correct. She thinks she's approaching a y value of 1. Will she actually reach 1? Yes, she will. Does that change the limit? No, it doesn't. So you might reach the number, okay, and the limit still exists, it's 3. You might not reach the number, okay, or you will reach the number y equals 1, limit's still 1, that doesn't change. You'll get the hang of it as we go. All right, 5-43. All the getting closer to talk in the preceding problems formerly called limits in calculus. Look at your graph of 1 over x minus 2 plus 3. Okay? As x gets larger and larger and larger, so as x goes to infinity, y goes to what we said, 3. Will it ever flip over and be under 3? No. Will it ever actually reach 3? No. But it's going to get that close to 3, we're not going to be able to tell the difference between where we're at and 3. Okay? Now, if I wanted to write the limit statement for that, okay, what that would look like here in this problem is the limit of f of x as x approaches infinity. So as x goes to forever equals, what does it equal? It equals 3. Remember, the equals is always a y value. Okay? The equals is always a y value. Let's try another one. What about the limit of f of x as x approaches 2? I'm going to throw a little symbol in here. All right, as x approaches 2 from the right. What does that equal? So first of all, locate that x value of 2. Where is that? Correct. It's right here. It's our VA. Okay, it's our VA. So if x is approaching 2, now if you're approaching 2, you could be coming from 2 different directions. So that's why we need this little symbol here. That means from the right. Plus. Makes sense, right? Because a plus symbol is on the right side of a number line. So from the right, that means we're coming to 2 from this side. So I'm right here. Okay, and I'm approaching 2 on my curve. I'm on the curve. I'm getting closer to the x value of 2. What's the curve doing? The closer I get to 2, the closer the curve goes to what? What y value? Remember, limit's a y value. Okay, where's my curve going? It's going to infinity. Oops. Not 8. Infinity. Okay? Let's try another one. The limit, I'll write over here, hopefully you can still see. The limit of f of x as x approaches 2. And what do you think that symbol means? Well, if plus meant from the right, that means minus is going to be from the left. So now I'm approaching this same asymptote, but now I'm coming from the left. So which curve am I on? I'm on this curve right here. I'm getting closer and closer and closer to the asymptote. As I do that, what's happening to the curve? Where is the curve going? What y value is the curve going to? Yes, it's going to where? Negative infinity. All right, it's going to negative infinity. Okay, and that is our 10-minute window. Go ahead and look up 5.2.1 part B for the rest of the lesson.